As I was introduced, my name is Prashanth. I'm coming here from Bangalore. I am part of Google Cloud. I've been with Google for a little over 7 years. I am a developer advocate with Google Cloud, which means I help folks understand how to use cloud, help understand concepts, and help you be successful with Google Cloud. I also lead a small team of advocates across the globe. Awesome. So with that, let's get started. Let's talk about the cloud innovation and how you can ride this wave. Just for me to get an understanding of this audience and decide whether I'm going to finish in 5 minutes or I'm going to finish in 30 minutes. Maybe a few questions just to understand you folks better. How many of you here are students? Non-working? Good. How many have some familiarity with cloud? Do something on cloud, development on cloud? Awesome. Anyone here has more than 5 years of experience? Not too many. I'm not going to go beyond that. I have only 5 years of experience. Did I say that? So I'm among you folks. Awesome. Is this familiar? Is this screenshot familiar to any of you? Let's have something like that. Awesome. I just see one hand. Really? No gamers here? Or is it more of Fortnite and other things these days? Okay, few more. If you don't know this, the one on the right side is Age of Empires. I am dating myself really badly by saying I used to play those games. This one is Civilization. There is actually a theme in these games which is going to be throughout my talk. Since none of you are too familiar with this, let me... So this is a real-time strategy game, right? And the whole idea behind this is how you start off with what is called the Stone Age, which is the Age of Empires. You research technologies, build on technologies, expand your empire, expand into the future ages, right? Sort of what's been happening to us, right? So try to bring this on as a relation between, games and real world, what you can learn actually from games. There's this interesting quote, hopefully by Albert Einstein. You can never trust any quotes you find on the internet. But I like this. If you want to know the future, look at the past, right? So this is sort of the theme for this talk. What I want to explain to you is how we have been coming along over the last centuries or years, right? And then what can we look forward to going forward? Have you heard of this term industrial revolutions or industrial revolution? Yeah, I can see some shaking head. How many industrial revolutions do you think have been there in the world? 10? 4? Yeah, 10 is a little too much. I hope we don't have 10 revolutions by our lifetime. It's going to be a nightmare. It's going to be a headache to keep up. We've had 4 revolutions, right? So the 4 key revolutions, this started in 1760s by mechanization. The next revolution is what we like to call the second revolution, is a mass production revolution. The third revolution is a digitalization. This is a revolution we are in today. And there is one more coming up. The 4th generation is the AI revolution. So we'll talk about each of these, right? It's important to understand what happened in these revolutions. This was actually a conversation I was having with one of those AI chatbots. I'm not going to name which one. But I was having a philosophical discussion with it, right? Literally, I was talking to it, right? You are innovating so much, you're doing these things, what does it mean for us, how can we keep up, and vagera, vagera, right? So I was having some random conversation. Not getting sleep, this is what you do. But it's important to understand what's been happening through these 4 revolutions. The first revolution was when was signified by the invention of the steam engine. Till then, we had an agrarian society. Everything was manual labor. People used to do things manually, right? Then the steam engine came, handicrafts changed for the first thing. So powered looms came in. Essentially, they started mechanizing things, right? From manual labor to actually mechanizing. Again, that's why I said automation, yes and no, because you could say that this was automation. Not necessarily, but it was essentially mechanization. A lot of people lost their jobs, right? Skilled labor, people who used to do work by hand lost their jobs, but a lot more industries and innovations were created, right? So manufacturing, transportation, mining, these all came up, right? Steam engine, you had to mine coal, you had to mine iron ores, all those things came up when this happened. Then mass production happened. This was signified by electricity, right? Electricity was invented, assembly lines came up, more automation. Things started flowing from one system to other system, one machine to another machine. Telegraph and communication came up at this point of time. And more new industries, right? Automobile, electrical, telecommunications. and digitalization, right, which is the world that we are in, I really, honestly, I don't know if it's digitization or a digitalization. Whenever I read this word, it feels like, we call this dog, right, Pomerian or Pomeranian. I have no idea. So is it digitization or digitalization? Yeah, you never know. Anyway, so what happened here was movement from analog or mechanical technologies to digital technologies, right? This marked the big difference. What you're also seeing here, and okay, let me finish this. And this brought about, actually, this is where the automation came in, right? Robotic automation came in during this point of time. You have the assembly lines, things being built through these robots. More new industries, right? IT, software, e-commerce, and so on. And it's interesting to see what is the AI revolution is going to bring in, right? This is something we are discovering, we are trying to find out. We are still actually in the digitalization revolution. We are going towards AI revolution right now. Yeah. So this is sort of where I was telling, right? Philosophically discussing with that chatbot in terms of what is doing. Realize that, humankind doesn't like to stay still. We like to innovate, we like to learn. We like to, when something is going fine, you want to see how to make it better, right? When you make things better, when you change things, when you invent new things, there's always disruption. Now it is up to us, and that's where we have been so successful at, how can we cope up with this disruption, right? How can we learn something new? How can we move forward with these changes and adapt to these changes? What you see here is also the timelines, right? The first industrial revolution lasted for about 100 years. The second was much shorter. The third is hardly 30, 40 years, 50 years now, right? So things are closing, right? Maybe the fifth revolution will be upon us in another 10 years. You never know, right? So the rate of change is exponential, and it's important for us to actually keep up with that. Third revolution, which is the digitalization revolution, or the IT revolution, as you call it, there were two important things that were punctuated in this revolution. One is what you see in the top right. What is that? IC, microprocessor, invention of microprocessors. And what is that logo? The internet, right? These were two key things that happened during the IT revolution. So there were, what essentially this meant, right? It meant first thing is the hardware, availability of hardware, miniaturization of hardware. We had an explosion into personal computers, right? Everyone started getting access to computers. It was not these huge mainframes machines sitting in one corner. Everyone had access to computers. They themselves got miniaturized, and now we have mobile phones. The mobile phones that we are using, you would have heard of this a lot of times, is probably a lot more powerful than the PCs or the laptops we were using 10 years ago, right? The next thing that happened was globalization, right? Collaboration. We were able to connect out to other countries, to other regions outside the globe. We were able to work with them, share information with them. And this information was also disseminated in a very nice way through the advent of the internet, right? So access to information, there's so much learning, there's so much collaboration that's been happening. The thing when that happens also is that the pace of advancement changes a lot more, right? Because it's not just one person working on it. Literally think of it like parallel computing, right? Whereas one person is thinking about innovation, you have the entire globe, you have all the leading researchers across the globe thinking about innovation, working on different topics. So that drastically changed, and that is why we see this acceleration, right, in the third industrial revolution, and we're going very quickly to the fourth one. So with that, the biggest change that happened in the third revolution, in the digital revolution, was, of course, cloud computing, right? Cloud was born during that time. So what is cloud computing? Does anybody have any answers? What do you think is cloud computing? It is availability of compute or storage as a utility. What does utility mean? Electricity, gas, these are utilities, right? Utility bills, right? Bill payments and so on. Essentially, yes, what you said, you're using something, you're paying for using something of somebody else, or somebody's offering you something as a service for you to pay and use, right? That is what it is. First thing is this has to be made available. The second thing is sharing resources, right? So it's not dedicated resources, dedicated computers, but sharing of resources. And third thing, of course, is accessing from anywhere, right? You don't have to go to an office to use the computer, but you can use it from anywhere. These are the key things that punctuate what is cloud computing. Who knows what was the first service that was regarded as a software as a service or classified as a compute? General literature says that, again, I don't know if it's true or not, I'm not a historian, but from all of my reading, I know that I've heard of the same name come up multiple times. It was Salesforce. Salesforce was created in 1999, made available in 1999. That was the first service that is widely regarded as a cloud computing service that has been offered. In fact, in 1961, the word cloud computing was defined. So a late Professor John McCarthy, he defined this term cloud computing, and that's where he said, right, the cloud, what is this? Or he predicted, computing will one day be sold as a utility. Interestingly, this professor also coined another term. Anyone wants to take a guess? Which is the buzzword of today? AI. So this professor also coined the term AI. So cloud computing, AI, relations, you know where the talk is heading towards, right? Okay. Let's talk about the history a little bit, right? And again, audience here, not too many folks have been living in the 80s and 70s or studying in the 80s and 70s, so I'll give a little bit of history. Maybe you know this more than me from what you have studied. I would have probably studied all this 20 years back, but it's important, right? And I'll tell you why this is important when I come to that section. We started, of course, with mainframes. You had these huge machines sitting in central research labs, science labs, and it was just lying there idle, right? Only used by scientists and researchers and so on. They were centralized, they were massive, large, expensive, and then we started creating these concepts called time sharing, right? People could book a time, use the same computer, book a time, go there, run their punch cards on it for 1 hour, come out, right? Run their algorithms for an hour, come out, and so on. Then they also started introducing the concept of virtualization. So time sharing is more fixed blocks, and then virtualization is more real-time, multiple people using some resources of the computer. This started happening, right? And then there was this thing called grid computing. I don't have the notes, but I think 1970s, somewhere around 1970s was this term grid computing defined. This was when was the first cloud computing, essentially, right? There they started giving this concept of shared resources, distributed systems, multiple systems pooling their power together to solve a specific task, right? And this was also this advent of utility computing where you would pay for using some resources. This all started happening back there, right, 1970s. Another thing in terms of how cloud has been progressing, the first generation of cloud was in 2005. Who knows what was the first cloud service, or who was the first cloud service provider? Or the first cloud service, sorry? AWS, of course. 2002, if I'm not mistaken, was when they announced. Essentially, what it was still was centralized infrastructure, right? It had a server somewhere that you could use. But this brought about some very interesting advances in the way that we started working with the systems. By this time, software was the vogue, right? We had software programmers, people would write code and so on. But this is how the advent of client-server architectures came in, right? Because you had a machine somewhere which could do the processing, and all you need to do is access a service from that. Before that, you had desktop applications, right? You would download the app, get a, I don't know, floppy or a CD, floppy, that save button that you see on various apps. So you used to get that and then run your software on your desktops, right? But then this brought about this big architectural change, which is the client-server architecture. Of course, you had 2-tier, 3-tier, and so on. It made databases available, so you could store data on the cloud, right? Not just those static pages, you could actually store data, store transactional data, and so on. There were also a couple of interesting projects that spun up at this time. I think this was in 2005, which is the Open Nebula Research Project. Essentially, this defined how a cloud computing stack should look like, right? It should have a compute, it should have a database, it should have a network, virtualization, all those kind of things, right? So this was defined back then. Go read through this. It's important. Again, like I said, this is the Einstein's code, right? You need to understand how things progressed for you to make sense of what's happening today, right? So this is sort of giving you a bird's eye view into that. But this started defining, making it more consumable for the public, right? What does cloud computing mean for everyone? Second generation of cloud happened in 2012. This is when we started seeing actual cloud, right? What cloud is. Right? I feel very strongly about this, and I'll talk about this later as well. But this is where you had pay as you go, right? You don't just block a machine for a month, right? But you pay as you go. You use as you run your compute, you pay for that. This was when non-relational databases started coming in, right? So it's not just RDBMSs, tables, and so on, but you had your NoSQL. And these brought about certain practices, right? Like DevOps. So that came in during this time. Microservices as an architecture started coming up due to this concept, due to cloud evolving, right? What I'm trying to land here is that it is not, so as technology improves, you need to figure out better ways of doing your things with these technologies, doing what you do with these technologies. Imagine if you had the cloud and you were building these same old client-server architecture, those huge monoliths today, right? Neither would cloud advance. They don't see the necessity of innovating, necessity of doing a pay-as-you-go if you were building those monoliths, right? And it would basically be a flop, right? So you need to adapt with change in technology, understand how to use the changes in technology, right? That becomes very important when you start using some of these newer services. Awesome. So why did folks start using cloud? First reason why folks started moving to cloud was this whole, have you heard of this term? CapEx, OpEx, right? CapEx, OpEx, capital expenses, essentially when you invest into something, operational expenses, you use it as you pay along, right? The whole utility thing. So companies like this, no upfront investment. It was available on demand. Today I want 1 machine, tomorrow I want 10 machines, I can get it, right? Whereas otherwise I would go to a vendor, purchase my hardware, or plan for it in advance. This was brought about by the change in, by the 2012 innovation, right? The second gen of cloud started bringing this. Flexibility, pay for usage, we spoke about this. Maintenance, imagine if you had to run your own machines, run your own servers, and many people do this today with private cloud, but they already have a lot of investment in there. You need to take care of electricity, power backup, right? What if power goes, your generators, your UPS, networking, ensure that you have load balancers, plug into, these leased lines so that your network is already available. These are things that you need to do. Taking care of security. The key thing with cloud, and this is a very important topic, it's something I'm passionate about, but I'm not going to spend too much time today, is security in the world of cloud, right? What has changed is, whereas your application was run inside on a central machine somewhere which is logged by gates and which has a security access code, now anybody can access a machine, anybody can access a service anywhere, right? Which means the number of surfaces where it can get impacted or where there's a security loophole is a lot, right? So you need to consider security. But then this is something that they gave away to these cloud service providers, right? People didn't have to invest into this. Upgrading your machines, updating your software, patching your software, vulnerabilities, all of this is taken away from you. And this is how cloud started becoming popular. It took a long time. People still started using, private cloud was the vogue, and then people still started using these VMs, ended up doing this, your updates, patches by themselves, but we're moving away from that world. Also created multiple service models. So the quintessential thing is software as a service. Honestly, I am not a fan of calling this as a cloud compute because it's just using a service that somebody else has built out. What does it mean for us as developers, right? What do we build? Infrastructure as a service, right? Where you have these VMs, you have your computes, you have your databases, essentially VMs, right? You have your infrastructure available where you run things on it. Platform as a service is actually, for me, the way forward, right? This is where you don't worry about the infrastructure itself. You can go on and actually start using whatever service is available, consuming it, do the pay-as-you-go thing. Couple more new kids on the block, functions as a service. For me, this is something that a lot of people talk about, a lot of people are interested in, but are not using it the right way. So desktop as a service is something that's coming up of late, right? This is where you don't even invest in your own workstations or development machines, but you use that also as a service, right? Let's say 24 hours in a day, you're probably coding, hopefully not, but 16 hours in a day. What are you going to do with your machine for the rest of the time, right? So use desktop as a service, use these machines for the time that you need to use it, right? And not all of the time. So this is actually becoming very popular. A lot of cloud providers are coming up with desktop as a service these days. We spoke about the industrial revolution. We spoke about how cloud came up during the third revolution. But cloud itself has innovated, right? Has made a lot of things happen. So let's talk about some of that. There were a lot of technologies and a lot of new concepts that were created during the cloud era. The idea behind the whole containers is cost optimization, right? If you look at it, keeping everything aside, right? Elasticity, scalability. You can only do that if you have the smaller chunks, right? You pay as you go. Essentially, you're looking at efficiencies, right? How do I spend the least amount of money possible, as well as how do I serve my users if there's a surge in traffic, right? And containers help with that. What else? Big data, absolutely. Who was that? There, yeah. Big data, absolutely, right? Imagine, and yesterday I looked at some of the data that was created in the last 1 year or so, and there's a term called zettabytes. I've lost track of this, right? I think gigabytes, terabytes, and then I don't know what all they're going into. yottabyte, zettabyte, exabytes. Now I don't even know what order it goes in. If it was alphabetical, it would have been easier. Anyways, my desktop has like 4 terabytes of space, right? How big data is not possible with servers, with machines. You need storage at a global scale, at a distributed scale, right? Data is coming from multiple devices across the globe. You need to be able to store it where it comes from. So it is not possible to have big data without the cloud. That's a very important technology. Okay, I'll just go forward. Big data we spoke about. Data engineering as a role or as a concept has come in because of the cloud, right? You have this big data, as you said. What do you do with this data? You need to do something with this data. So the whole concept of data pipelines, data engineering, processing this data, this came in only because of the cloud. It wouldn't have happened without this, right? Data analytics. What do you do with this data now? Make sense out of this data, right? Data analytics as a stream came up after cloud. Machine learning, of course, right? You could do machine learning, you could run things on GPUs and on your laptops and so on, but it is not scalable. You need really powerful compute. Today's world, the large language models have been trained for months together, right, on multiple thousands of machines. You cannot do that if you don't have the cloud. We spoke about the whole microservices, containers, CI/CD, right? What do you continuously deploy if you didn't have the cloud? Would you continuously deploy CDs? Like, have a postal service and go give people CDs of your software? No. Cloud created this innovation. Event-driven architectures. How many of you have heard of this? Cool. This is a buzz these days, right? I don't know. I've been doing a little bit of let's say, performance analysis of event-driven architecture. So I've taken the same application, have it as a monolith, have it as microservices talking to each other, and have it as an event-driven architecture, right? I'm doing some benchmarking and stuff like that. But it is all the rage. So these days, people want to do more event-driven services. There's a little bit of an overhead with this, honestly, but it helps you with the pay-as-you-go, the flexibility side of things, right? So look into this as well. This is something that's that's happening. Serverless is what I really want all of you to take away with. Serverless, for me, is the way you work with cloud, right? It is not spinning up a database. It is not spinning up a VM or not even, I don't know, to the level of Kubernetes, right? Running serverless is essentially you focus on the task that you want to achieve. Let the cloud providers take care of everything, right? So serverless essentially means, and again, it's a misnomer. I'm sure all of you know this, but serverless doesn't mean there is no server. Duh. Essentially, you don't care about that server, right? That is what serverless is. So I prefer the term fully managed. It is elastic, highly elastic, services spin up, down, based on your consumption, your demand. It helps, from a business point of view, it helps with time to market, right? Imagine the time you just write a code, write a functionality, and ship it. Don't worry about anything else. Don't worry about firewall rules, load balancers, nothing like that, right? So time to market, it helps businesses innovate. Any of you folks are interested in creating your own startups, you have to start thinking with serverless. Right? This is the only way you can get your things out soon, innovate on it, iterate on it, and see if it's working or not. Of course, some disadvantages. There is this cold start problem, which means the first time that you spin a service when it is not running, it's going to take a lot of time. Your user will wait 30 seconds, they will get bored, they will go away. Right? You have to take care of certain things like that. It cannot manage state, right? Because servers go up and down, or the instances go up and down, so you need to find a way to manage state. Again, this is an architectural problem that needs to be solved. A lot of use cases that come up. APIs are a great use case for serverless. IoT, one of you mentioned, right? So IoT is a great use case for serverless. Data pipelines. As the data comes in, process it, get done with it, push it into a database, store it somewhere, right? Those are very great examples for using serverless. So look at serverless, right? I mean, honestly, it is very much misunderstood as a concept as how to use. Serverless, for me, is the future, is the trend, the way we are going towards. Finally, some future trends, right? Where are we going towards? Who knows what that is? Yes? Quantum computers, right? Except it's outside. It's the internals of a quantum computer. The quantum computer will be in some very low Kelvin temperature inside an ice bath and things like that. OK. So edge computing. Edge computing is one of the future technologies. So compute and storage closer to source. The important thing here is there are two things. So latency is one thing. Data transmission bandwidth. You do a lot of processing on the data when you get it, right? Is this data relevant for me or not? Is there something, what should I do on this? All of that can be eliminated when you do the processing itself close to the source. Not just collecting the data close to the source, but processing it close to the source. And then send to your cloud servers or centralized servers only what is relevant. Then next thing is hybrid, multi-cloud, sovereign cloud, open cloud. Have you heard of these terms? Essentially, it is a country, right, or a region. Administrative region is what sovereign means. This is, the world is going towards this, right? A lot of data security, data residency reasons are coming in. Countries want to keep data, keep processing within their boundaries. So sovereign cloud is becoming very, very popular these days. Managing your resources centrally. So with hybrid cloud, you can have your edge computing, you can have your things everywhere else, but you manage it centrally. I am out of time, but let me quickly finish this. Vendor lock-in. Open cloud is something that is avoiding vendor lock-in. Using Apache Spark and running it on different clouds, different data providers, right? So that you can then go to anybody else. If today not Google Cloud, you could go to some other cloud provider tomorrow, right? So removing vendor lock-in. Finally, quantum computing, right? This is interesting. Can you draw a parallel between quantum computing and something I spoke about before? Mainframes, 1970s, 2020s, we are sitting and doing mainframes all over again, right? But this is the opportunity. That's why I said, no, look at the past, learn what we did back then, and see how we can apply it today. This is where you need to come in, right? You need to think about these things. How can we use quantum computing? What are the use cases? How can we make it accessible to everyone else, right? So this is becoming big. We need to figure out what to do with it, how to make it accessible to everyone. Final thing, artificial intelligence, the AI revolution. Essentially what this means is it's merging the boundaries between physical, digital, and biological. It is punctuated by what we like to call intuitive interactions, right? Imagine writing a search term on Google search versus talking to one of those chatbots. Natural conversations, right? Powered by language. Machines are able to understand human language. So this is what the AI revolution is coming up with. We need to figure out how to best use it, right? It is not a playmate, just keep talking to a chatbot. That is absolutely useless. But we need to figure out how to make it more relevant. Imagine asking for data instead of writing a SQL query, you ask the system, and it's able to pull the data, pull the information, do your joins, do your queries with you. Right? Actually, it's a great segue to the next talk, but these are the potentials that we have for AI. Some of the things we have spoken about all of this, I'm not going to touch on this. So AI, robotics, genetic quantum computing, all these are going to be powering the fourth revolution. We need to see what to do with it. In conclusion, technology is evolving rapidly. Cloud is evolving even more rapidly, I would say exponentially. We need to keep pace. 3 things that I want you to do. Focus on foundational knowledge. Understand how something works. When you talk about serverless, how does it work? Not that it's something for me to use, but how is it built? What is it designed for? Use your foundational knowledge. Apply your foundational knowledge. Focus on efficiencies. We don't want to spend time doing unnecessary things. Spinning up a hardware today is unnecessary. Let's get out of it, right? Let's focus on using that hardware. Focus on efficiencies. Focus on how to do your work more efficiently. Focus on delivering business value. It's great to be a geek doing stuff with technology, soldering your ICs together. It's not going to serve any business need today. Focus on generating business value. Stay informed. These meetups are an amazing opportunity to learn what's new, what's happening, explore some trends, try out, don't just listen to it, try out certain things, and build your expertise in the areas that you're interested in. Right? This is what I will leave you with. Thank you so much for being a great audience. Google Cloud Innovators, shameless plug. Thank you. So you can sign up for this. You will be getting these newsletters and other things, latest information will be shared here, occasional special offers. And I am Prashanth. I am available as KS Prashu, usually everywhere on the internet. Feel free to connect with me, Twitter, LinkedIn, wherever you would like. Thank you so much.